Welcome, everyone. Welcome to this AWS Discovery Day webinar. Today's topic will be Introduction to Prompt Engineering, or AI Prompt Engineering. Let's get started. Introduction to Prompt Engineering. So, our agenda here in this presentation, there will be three sections. First, a high-level overview of foundation models and large language models, or LLMs. Then part two will be examination of some key concepts of prompt engineering, the best practices for constructing a prompt for an AI. And then part three will be basic prompting techniques, which include some additional techniques like you see listed here: zero shot prompting, few shot prompts, chain of thought prompting. And we'll see some examples of those along the way. So, first, to start with the introduction to foundation models and large language models. So, foundation model. So we start with an AI. An AI is based on a foundation models, and the foundation models can come in different forms. What we will see is the uh, foundation models, and we'll see some examples of tools we can use with those. But with the foundation models, we're starting with some sort of data set, and typically foundation models, the AIs that are common that we use today, usually perform what's called self-supervised learning, where they use unlabeled data. Means there are no labels, so there are no clues or hints or information about what the data might be. What is the data? What does it mean? A label would be something like if we were looking at an image, for example. A label would be a simple label, just be, well, this is an image of a dog or a specific, species of a dog, a German Shepherd or something like that. But normally the large language models we're used to dealing with today trained on unlabeled data. The foundation model itself learns what the data means by examining large amounts of data, very large data sets. That will generate a foundation model or an FM, which can form the basis for additional specialized models if we do some additional training. Or we can use the foundation models, as they are after they've gone through the pre-training process. And they excel at doing a number of different things. Foundation models that we're familiar with today, probably the most common will be the text generation, but also they can do things like such as text summarization. I provide a file to them, like a PDF document or something, and have them summarize that, or an email, a long email string, perhaps. They could extract information from input they're provided. You have text to image type models, which can generate an image. You have chat bots you may have encountered on various websites out there, a chat bot assistant that's helping you with some issue you're experiencing or helping you with navigating the site, perhaps, and a wide variety of other tasks. So when we're training foundation models, we'll start with the pre-training phase where we create the foundation model or the base, be the base foundation model at this point. And then further training could be performed in the case of fine-tuning a foundation model. Fine-tuning a model means, well, we're going to add more data and use that foundation model to do additional training on an additional data set to refine the model for some specific task, perhaps. Or additional training of a foundation model can be achieved with prompt engineering, which is the focus of course, this presentation. We want to make the distinction, though, with the fine tuning. We're adding additional data, combining it with the original base foundation model, and then you get a new, you altered foundation model. After the fine tuning, you're actually changing the model, changing the internal model parameters based on the data that you provided. Prompt engineering doesn't require any additional data. So maybe no additional data other than maybe you provide some input data in the form of a file you wanted to summarize or something. But we're not going through the training process with prompt engineering. You're not actually modifying the model. Prompt engineering does not change the underlying foundation model itself. Prompt engineering is simply a series of techniques and best practices for extracting more accurate answers from a given foundation model. So, types of foundation models that are common today: text to text to image, text, and there are others, text to speech, text to video, image to text. You provided the foundation model an image and it generates a text description of what it sees in the image, and so on. Probably text to text or text to image. You're being some of the most common types of models. So the text to text models, we have models such as your Chat GPT, of course, Claude, the Claude Claude model from Anthropic. Amazon has their own Titan model. Meta has the Llama uh, 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 foundation models. Text to image type models would be things like Dolly and Stable Diffusion and Midjourney. That's just some examples of some common foundation models, AIs that are out there today. And the models we're dealing with today are primarily large language models. LLMs are not the only type of AI model, but certainly the most common, the most prominent these days, where you can provide some input in the form of a question, perhaps, in the form of a document that you want it to summarize. And the LLM will process it and then produce some output, of course. For the LLM, really the primary driver and why there has been such an explosion in foundation models and AI is this transformer architecture. First introduced in 2017, so fairly recent. Transformer architecture probably is the single most important factor in contributing to the advancements in AI in the last several years. This is a very brief overview of transformer architecture. This is, in fact, we have GPT type models, like in Chat GPT, for instance. That is, what's GPT? What does that stand for? Generative AI. Generative meaning it can generate new content. It can generate text content. It can generate an image that didn't exist before. Generative, pre-trained. So it's a pre-trained foundation model. It's been trained on large sets of data. And the T is transformer. Transformer part of that. Generative pre-trained transformer. Transformer being that architecture that the process, the mathematical algorithms of consuming data that it's being trained on. The data is converted into what are called embeddings or vectors, which is a mathematical representation of different components of the data. And then that being is used to form patterns or recognition patterns, pattern recognition, and associations between the data. Because really, your foundation model is really based on and grew out of machine learning, which is really all about pattern recognition, and that's what the transformer architecture is doing. It allows it to predict the next the next word or the next piece of content based on what has come before. It's able to predict the next word, and that's how it goes about generating the output that you receive. You type in a text question, you get text output. It looks at your input and question, it determines what would be appropriate output for that. Some of the advances, which makes the transformer architecture so attractive, highly parallelizable when we're doing the training of a foundation model. It takes a lot of compute resources, so this can be done in a fairly timely manner. I mean, it's faster than previous ways of doing the training, but it will train on the data that is provided, the data set all at once. It consumes all of the data at once in a parallel way, which can take less time to train, but requires enormous amounts of computing resources, specifically resources such as GPUs, like NVIDIA graphics processors, for example, because of the way they process and deal with math. A graphics processor, they excel at being used to train foundation models. So this is really the key component to the development of what we know now as large language models, this transformer architecture. The transformers are really a form of a neural networks, meaning the way it's designed and the software design is intended to mimic the neural networks in the human brain, where you take the input in the form of what we call tokens, which if we're dealing with text, a token could be a word, a portion of a word, a phrase. It's part of the input that the model breaks up into the tokens. If the input was an image, then a token will be different patches and areas of an image and so on. And the tokens are then processed in this embedding layer, and it generates it's called a vector or a sort of mathematical representation of the tokens. There's another layer of the transformer called the feed forward layer, which is providing additional contextualization, processing of those vectors, determining the relationships between the vectors, which are representations of the tokens, which is your original input that you provided, or the data that the model is being trained on. There's another part of the transformer called the attention mechanism, which is designed to extract the most relevant parts of input text to help get the most accurate results in your output. So some of these LLM type AIs and use cases, what are they useful for? You probably encountered these many times in just daily working with your internet type applications and websites. It can be chatbots on a site, a help chatbot assisting you with your order or something. Some sort of agent assistant, even on on the phone if you're calling for support. The chat LLMs can also be used and assist in code generation to assist developers in writing code. Can summarize reports. They can be used to summarize and generate marketing material, generate the new product development, generate media and entertainment content in the form of images and video, process documents. You can feed the AIs, feed them documents. Of course, there are limitations. You would either work within the limitations of whatever particular foundation model or AI you might be using as to how much input they're able to process. Also, LLMs we use since really at their core, at a very basic level, it's about pattern recognition, be able to predict the next, say, word in the sequence of words, for example. Pattern recognition will also include things like fraud detection in the financial industry, for example, looking at your banking transaction patterns. It could also be used in threat detection, like cybersecurity threat detection, where it could be used to examine the behavior patterns of traffic that is being generated against a web application. And we might find some anomalies or some patterns that are unusual or possibly malicious. So as we talked about with the foundation models, we have the pre-training of the foundation models. It generates the base model. Then we can go two routes after that. We could have some fine tuning, or we could use prompt engineering. Prompt engineering is the fastest way to get accurate information, useful information from an LLM. So we're going to look at concepts of prompt engineering. So as we discussed there a few minutes ago, in the fine tuning, we are fine tuning. You start with a we start with a base foundation model. If we are going to fine tune the model, that's where we need some additional data. And then we're going to train the foundation model again, go through another round of training, which will result in actually altering the model. So the output of this would be you have a new modified type of foundation model. It's not the same as what we started with. And fine tuning then might be necessary in some cases if you need a foundation model and your AI to deal with a specific domain or realm of information, such as, oh, you want it optimized to be to work in a medical environment, some sort of healthcare industry. Going to train your base foundation model on medical journals and articles, or you have some your proprietary private information from your organization. You want to train the foundation model on that, so it's familiar with your proprietary, design for your product or whatever it might be. So you'll end up with a new foundation model that is optimized for some particular task or some particular domain of knowledge. Now, that will take time and money. You'll need some computing infrastructure. You'll need a well curated data set to do the training on. And it's going to take more time, more money, more effort, expertise with data scientists and machine learning engineers and so on to do that sort of thing. So the fine tuning, there's a lot more work going on there and cost and expense. We're going to focus on prompt engineering, which was the what we're looking at down here. We're looking at prompt engineering. With prompt engineering, how's that different? You are not modifying the foundation model in this case. You're not modifying the FM. You don't need to provide an additional set of data because we're not doing any training. All you're doing is learning the best practices, the techniques to how you phrase and present the question or the task to the model, allowing you to get the best results. Now, as we'll see, we'll get some basic suggestions and guidelines here. This is not really a science or how you design a prompt engineering. There's some best practices and guidelines you should definitely follow, but may be different for different AIs. Some of the things we will see here won't necessarily work with every AI. You would need to fine tune your approach for the specific AI you're using. Read the documentation that's provided to the AIs like Claude and ChatGPT and so on will provide information about how best to construct a prompt for them for that specific AI. We're going to focus on prompt engineering here, which no additional training. You don't need computing resources. You don't need a data set. So it's the fastest and easiest way to get more accurate results. So we'll start with the elements of a prompt. What are the elements? Well, there are four elements, and this varies also. You may see other variations on this, but we're going to consider four elements of a prompt: the instruction, the question or the task that we're asking of the AI, context, any input data like a file we might wish to provide, and then the output indicator. See what does that mean? So let's look at an example. Let's look at an example of a prompt. So here's a prompt I might provide, say, to an AI. I'm going to enter and give the AI instructions and a task. The task here would be, well, let's write a summary of a service review using two sentences. And then I give it a little bit of background information. This is an online store. One of the services is shipping. And then I provide some input data, input information in the form of, well, here's a review, and I want the AI to summarize this. And then I provide a little example prompt at the end. Just here's summary. Provide the provide the summarization, and the AI in this case provides the output like we see here. So we can identify our prompt best practices here in the different parts of the prompt in this way. So if we look at the initial instructions, actually two things happening in the initial instruction and the task we're asking of the AI. So we're giving instructions, we're to write a summary. That's the instruction, the task. And then I gave it limitations on the output indicator. I want the summary in two sentences. That's what we mean by the output indicator. You're describing what sort of output do you want. You can limit it to, single paragraph, two sentences, some other format. You could put the summary in the form of a poem or something along those lines. And you can try different things with different AIs and see how it works. And then there's the context. The context meaning other additional information and any background information that would be useful for the AI. Here we're telling the AI that, oh, this is an online store, so it's something found on the internet. One of the services involved is shipping. It would be shipping something to individuals. But then the input data, in this case, we just copied and pasted some text. Often you'll be able to upload or attach a file if it's a text document or a PDF or something possibly. And then summary, this is also output. We need to consider that output too. It's giving it a prompt of, well, here, provide the summary after you gave you this input information. So instructions, context, input data, output indicator, right, are some of the components of a prompt. Now, what about some best practice? Some general best practices when you're prompting an AI? Be clear and concise. Clear and concise. You should use natural language. Put your questions in the form of a sentence, your natural language, just like you would if you were talking to another person and asking them a question. Don't use ambiguous words or phrasing. Should be natural flowing language in a coherent sentence. Especially avoid isolated keywords and phrases because you're dealing with the foundation models, these AIs, LLMs. This is not a search engine. Not an internet search engine. You might be able to type in a word or a couple of words or an incomplete phrase, something along those lines, and still get some results. And it won't necessarily work very well with a large language model. Best to use a complete, natural sentence. Include context if needed. Information like we saw about the type of store in that previous example. Include information about maybe the type of business if you're asking the model to analyze some business results or analyze what a business does. Use directives that is sort of related to the output. Directives for the type of response, such as like we saw in the previous one. We want a summary. I want you to summarize this review information, or I want the output in the form of a poem or song lyrics. Other things you might try if you want some more creative type of output. Include the output, and again, output be things like the limitations. That's where we had the uh, summarize this in two sentences, or it could be provide if you're asking it to explain a concept, you provide three different examples of this concept that I'm asking you about. Conclude your response, complete your response in a single paragraph. Perhaps would be another a type of output instruction. Start with the question is another best practice. Start with the questions. Primarily, this would be like the W's questions: who, what, where, when, why. We include how in that also. good form of starting off your prompt for an AI. Provide example responses. This is another thing we can also do. Provide an example response, in the expected format of the response, especially if the response should have some particular type of format, like the various date formats, for example. You could have, as is common in the United States, you have month, day, year type of format, but there may be other formats. We have maybe year, month, day type of format. If you want your output in a specific type of format or constructed a specific way, provide some examples for those responses. Also, you may need to break up complex tasks. Sometimes the LLMs can get confused if you have a long, elaborate your type of task or question you're asking. Remember, we want to be clear and concise. If it's a more complex task, you might have to break it up into multiple prompts, or there's another technique you could try to use. We'll see coming up here later too. And as I'd mentioned a few minutes ago, this is the prompt engineering is not really an exact science. You'll need to go through maybe multiple iterations and attempts. You're going to need to experiment, adapt your prompts for the specific AI you're working with. Different AIs will respond differently to different types of prompts. So you get different types of output. So you'll need to adapt as necessary. So we'll look at some prompts to see which of these demonstrates our best practices. So one of our best practices was be clear and concise. So I'll give you a few seconds here. Examine prompt one and prompt two. Which one demonstrates being clear and concise? You have the answer now? If you chose prompt number two, then you're correct. What is the sum of these numbers? Look at prompt one. There's a lot of unnecessary words here. So it's like unnecessarily complex. Where we're asking, will compute the sum total of the subsequent sequence of numerals. So it's overly flowery language, and we have unnecessary extra words that aren't really necessary. It's not clear and concise. It's not really to the point. So prompt one, not an example of being clear and concise. Prompt two, much better at that. So next, best practice. Include the context if needed. Which prompt demonstrates including context? You made your choice. If you chose prompt two, then you're correct. What is the context? The context here, well, first, the task of the question, we want a summary of some article. So we're going to provide the input in the form of the article where you maybe copy and paste the text here. And we're including context because we are describing where this summary will be used. Summary is going to be used in a blog post. So the output should be in a format of something that would be appropriate for a blog post. So context can also be used to affect the output, like we're seeing here. Context might also include something that I want to do something that'll be used in a business meeting, or it could be something that's used in a casual context, not a business type context. And you may get different types of output in that case. Prompt one, of course, is very simple question, clear and concise, summarize the article, but won't necessarily be optimized for our intended destination, a blog post. So prompt one, not an example of including context. Our next best practice, use directives for the desired response type. Which prompt demonstrates that. You made your choice. If you selected prompt number one, then you are correct. The desired response type or the desired output here would be I wish to have my answer in a full sentence. Provide a full sentence, not just the single name of the city, the capital of New York. So prompt two leaves that open to what type of output. It won't necessarily be in a full sentence. But the next best practice, consider the output in the prompt. Made your choice. If you said there's prompt number two, you're correct. Prompt number two is giving more specific instructions. Prompt number one is very general, right? Calculate the area of a circle. Maybe in this case, you probably, if you get any result, you may just get the formula for how to calculate the area of a circle, but we didn't provide any other specifics. Here, prompt number two, we provided more specifics. Of course, we gave it details about calculate the area of a circle. What circle? Well, this one. This circle's got a radius of 3 inches, and we provided the metric measurements. We wanted to round the answer to the nearest integer. So if you're dealing with numbers in the output, we could specify how many decimal places we want it to be represented. We gave more instructions about the type of output we wanted. And our next best practice, start prompts with a question. Which one represents us? Starting the prompts with a question. If you said prompt number one, then you are correct. So starting with the question, which is who, what, where, why, how. Why did this event happen? And then we also have another best practice here. We have specified information about the output. Explain in 3 sentences. So I expect the answer to come in 3 sentences. So prompt number two just leaves it open. Prompt number two might work. Probably would get some results, but it's going to depend upon the your AI. What about providing an example response? Another of our best practices, which demonstrates providing example response. You have your answer. If you chose prompt number two, then yes, we're providing examples. So we have posed a question or task for the AI. Determine the sentiment. Another thing that large language models are capable of doing. Reading a statement or a sentence and extracting the sentiment. Is it negative sentiment, positive? Is it angry? Is it happy, etc.? So here we provided some examples. We specifically are saying, here, these are examples. And then we give it examples of a in a particular format. So we also told it this is social media posts. And the post, great pen, and then followed by, we got some delimiting characters, 2 slashes between that. And then the resulting sentiment. They're positive in that case. The next one's negative. Then would provide our input, whatever post. We give it the same sort of format. We've showed it a couple of examples. Here's the example, or here's the post for you to examine. And then there's 2 slashes, and then I want you to provide the sentiment, after that. So it knows type of response or the format of the response it should provide. And of course, you have to adjust, modify your prompts as necessary, review your responses that are provided, and look at the quality of the response. Did it really answer the question? You can, by examining the response, you maybe see areas where you didn't phrase something exactly right. You left out some information, so the LLM didn't quite get the point of what you were asking, perhaps. So you need to modify your prompt and try again. Next, we're going to examine some basic prompt techniques. So we've looked at the best practices, being clear and concise and stating what output is desired and providing context and so on. There's some additional prompt techniques you could provide or you could utilize. One of them is called zero shot prompting. So, zero shot, by used in this context, shot equals like an example. Zero shot prompting means we don't provide any examples of the task or how to do it or what the results should be. So we pose a task or send a question to an LLM. No examples or shots of the task. And LLMs, especially these days, the earlier ones not so much. If you went back to Chat GPT-2 or something from a few years ago, they didn't work very well with zero shot sort of prompting. You get really bizarre, crazy just answers that were just really bizarre, and it's seemingly a jumble of words. But the LLMs that we're working with today, the more recent iterations of those, are very adept at working with zero shot prompting. When I use AI to ask questions, I typically do zero shot prompting for most AIs these days, whether it's current versions of ChatGPT or Claude AI, and don't really provide examples. Um, so I don't find it really necessary with most LLMs these days. But it can be utilized in some contexts. It is especially influenced by the larger the LLM, meaning what was the size of data that the LLM was trained on originally. Larger the data set, the more knowledge, the more patterns really that the foundation model is aware of, will generally get more effective, more accurate results. And then you might need to fine tune your prompt from that point in order to get effective results. Here's an example, the zero shot prompt example. We're asking the AI, tell me the sentiment of the following social media post, categorize it as positive, negative, or neutral, and then we provide the inputs. And the resulting output is just the AI telling me that, looking based on this input, this is looks like a positive, positive sentiment. Now, on the other side of that is few shot prompting, or there's also maybe there's a step in between. Sometimes we'll see represented single shot prompting, meaning now I provide one or more examples, provide the task, pose the question to the AI, but I provide additional contextual information or shots of the output that I expect. So this we'll see some examples of this where we're providing these one or multiple shots or examples of the output we desire. And we may need to provide labels. And here's an interesting thing about the way LLMs work is that the correct labels not necessary to get effective results, meaning you'll see some examples here, but you don't have to provide in your examples. It doesn't have to be actually, ground truth, we call it. It doesn't have to be absolute truth. It doesn't have to be, the label doesn't have to be true or accurate for the particular situation we're dealing with. It's the mere fact of providing a label that gives the LLM the idea of what the desired answer might be a desired format of the answer, or the type of answer. Just the way LLMs work, you don't necessarily need to be presented with ground truth to end up giving you an accurate answer. If you're providing these shots or these examples, you also have to observe the token limits of your LLM. Remember, we were talking about tokens earlier, transformers, and how it takes the input and breaks it up into tokens. Tokens will represent a word or a portion of a word or part of a sentence or part of an image or something. When you're providing input to the AI or you're providing examples, here in this case, the AI is going to break that up into tokens to examine it. And different AIs will have different limits on how much data can you provide them in the prompt. So if you provide a lot of lengthy examples, you could exceed that limit. You'd have to then use some mechanism for determining which of the shots you're going to provide, which of the examples you're going to provide, if you have a large set of examples to work with. So an example of few shot prompting could look like this. Again, with our sentiment approach, we're looking for sentiment of the following headline, categorize it as positive, negative, neutral, and then we list a few examples. Here are some examples. So telling the AI, oh, what follows are some examples. So you have a couple of examples of negative or positive. This is what we're referring to as the label. This is the part where this doesn't have to be accurate. This doesn't have to be correct. You don't have to give it the correct sentiment for a sentence, but you're associating with the LLM allows it to associate with it. Well, you have a sentence or some text, and I'm supposed to provide, the sentiment for that. It's not looking for the truth when you're providing the shots here. That's what we were describing before. And then I provide, here's the actual information, where the input down here that we want the AI to deal with, and leave the answer blank in that case so we can generate the sentiment. And then we get the output, a negative sentiment in that example. Another prompting technique. Another prompting technique is this chain of thought prompting. You see this written or represented like that sometimes, COT. This is a technique you might need to use if you have a more complex multi-step task. You may need to break that up into multiple prompts, perhaps, or you could try this chain of thought prompting approach where you literally tell the AI to think step by step, think through the process step by step. It's kind of like asking it to show its work. Remember, maybe you're in school doing your math problems, you had to show your work when you're solving some sort of math problem. That's sort of what you're asking the AI here. Very effective when the task involves several steps or requires a series of reasoning. Work through the task that's presented like this. So here's an example. Now we're combining this. We have chain of thought prompt, but combining it in this case with a zero shot. We're not providing any examples of the output. So we have multiple pieces of information in our input. We want here's a core task. Which vehicle requires a larger down payment based on the following information? And then I have here, and then when you're doing this in the prompt, most AI, if we need blank lines like this, a blank line, you don't want to press the enter key because that usually just sends your input to the AI and you'll get a response. So you don't want to press the enter key. Usually it's shift enter. You want a new line, but I don't actually want to send it yet I don't want to submit it yet to the AI. Shift enter will typically get you a blank line. And then I provide, here's my first example. So example A, another shift enter again for a blank line here. Here's my second second piece of information, the second vehicle. And then I'm instructing AI, think step by step like this. In that case, the output we receive from this AI does in fact show the step-by-step work. It's showing its work. It's showing how did it figure out? It knows, okay, we need to figure out the down payment. So here's the work I did. First example, like 30% of 40,000. Second example, 20% of 20% of 10,000 or 50,000 rather. And the result, then it compared the two, which one is larger? Vehicle A. It's a larger down payment than vehicle B. Here's chain of thought prompt example again, but few shot. Now we've provided an example of the output. So this is again a series of step-by-step reasoning to go through multiple steps to find the pattern and then predict what comes next. So what are we doing here? We're looking given week viewers for TV channel are as follows. Monday we had 6,500 viewers, Tuesday 6,400, Wednesday 6,300. So some of the input data we're providing. And then we provide a shot or an example that is right here. How many viewers can we expect on Friday? And then we provide the answer. Given the pattern, if we were to project that, predict that into the future, a daily decrease of 100, we stopped with Wednesday. So that means we could expect maybe 6,200 viewers on Thursday, 100 less, 6,100 on Friday. And then we get to our actual question. How many viewers can we expect on Saturday? Think step by step, given the examples and the information we've been provided. And the results are could vary based on the AI. So for example, if we take that example and go look at AWS. So on AWS, if you have an AWS account, there's a service called Bedrock. Bedrock is providing you access to a number of different foundation models. You have to go through the process of requesting access to these. Not all of them are available to all accounts, but a number of foundation models that I've uh, added to my account. And if we want to do text, chat, or text. Let's select a model. So Amazon Titan, got one model there. Let's see how this one works. I copy and paste that example. There it is, that we just saw. Run the result. No information about number of viewers on Saturday. So that format doesn't work with this AI. So you don't get the result we were looking for. It doesn't know how to make sense of this. Let's try a different AI. Let me get back to that. Let's do Claude. Let's go to Anthropic. We'll do Claude 3. I'll paste the same prompt again. And let's see what Claude 3 does for us. Claude 3 gives us more detailed answer. We're going to follow the pattern to continue the decreasing trend. Step 1, identified the pattern. Viewers were decreasing 100 per day. We continued the pattern through the example of the single shot we provided. Step 3, I'm going to apply the same pattern to viewers on Saturday. So therefore, we're predicting 6,000 viewers on Saturday. Okay, that is the expected result, showing Claude showing it step-by-step work. So we've examined a very high level overview of foundation models, large language models. and how the invention of that transformer architecture really accelerated things since 2017. Key concepts of the prompt engineering, looking at the best practices, be clear and concise, provide input and output examples, use natural language type questions, and then some examples of some prompting techniques or approaches, zero shot, few shot, chain of thought type of prompting. For more information, find more information dealing with machine learning and foundation models and AI and the variety of services that AWS has available for those things. Find more information at Skill Builder, a lot of digital online courses there available for you, or possibly some instructor-led classes if you wanted to enroll in a more formal class. You can investigate that at AWS's training and certification website. Skill Builder has a lot of information, a lot of courses, much of it free, but there's also a subscription side to Skill Builder to unlock additional content. That will conclude this presentation. Thank you very much for attending.